Welcome, Hornets, and thank you for showing up today. I'm going to be going over the two worksheets, Growth and Decay, number 1 and number 2. Now, we've already seen the notes for this, and if you recall in the notes, we were going through and saying when we have a rate that is increasing in number, a rate proportional to the current population, this is the dp dt is equal to kp. And this immediately tells me that I'm working with my population in terms of time is equal to the CE to the KT power. Now our C, or the constant, is going to be our initial value, which is the population that we currently have. We need to change our rate, which is a percent, into a decimal. Now remember, the word per means divided by, and cent means 100. So when we're changing that 4.4%, it's going to come out to be 0.044. So we end up having our population in terms of time is equal to 160 in millions to the times e to the power of t times 0.044. Now the time that they want us to work with is 8.3 minutes from now. So we're going to use our calculator and we're going to use that time. So putting it into my calculator, I have 160 in millions times the e to the power of the 8.3 times 0.044. We hit enter, and we're looking at a population in millions of 230.528 millions of E. coli bacteria. And that's the answer to number 1. When we look at number 2, what we are looking for is that wording. The rate of increase in a number that is a rate proportional to the current population. With that, I know that I'm working with P of t equals CE to the KT power. We know that we have a rate that is going to be 0.018 since we have 1.8%, and when we divide by 100, it moves the decimal twice. We have our initial population of 154 in millions, and so we can put together our equation. P of t equals 154 e to the t times 0.018. They want us to then find our population in 7.2 minutes from now. So we're going to put this directly into our calculator, and we're going to have 154 times e to the power of, and we're looking at 7.2 times 0.018. When we hit enter, we end up getting 175.309, and once again, this is in millions of E. coli bacteria. 175.309, and this is in millions of E. coli bacteria. Going to number 3. For a period of time, an island's population grows at a rate proportional to its population. That's the words that we're looking for to know that the population in terms of time is now CE to the KT power. If the growth rate is 4.8%, so I'm putting my P of t, the current population is 1,517. I'm going to put t times 0.048. We want to know the population in 7.8 years from now, so we're going to put that in and plug it away. 1517 times e to the power of 0.78 times 0.048, enter. And we're looking at 2,205, and we have that 0.898. Now, if we were on an AP test, they would say round to the nearest value or round to the nearest population, in which case we would say it is 2,206, and this would be the coyotes within that growth. Number 4. Rate proportional to the current population. So we know we have P of t is equal to CE to the KT power. We're going to put in 120 in millions. We have 3%, so we have 2 times 0.034. And we're now going to use our time of 6.8. And you'll notice this goes fairly quickly. What makes life difficult is if we don't recognize that word, the wording, the rate proportional to the current population. So let's go ahead and put it in. 120 e to the power of, and we're now going to put in 6.8 times our 0.034. Once again, just a reminder, this is in millions, and we have 151.213 in millions of E. coli bacteria. And that's the worksheet number 1. I hope that helped. Thank you very much, Hornets. I'm going to be doing the Growth and Decay worksheet number 2 in just a moment. Thank you very much. Please have a very good and safe weekend and a happy holiday, and we will see you all when you return. Thank you very much, and be well. Bye-bye now.